You guys picked up this sheet on the way in. Hey, if you didn't get one, you need to quietly walk up and grab one right now. We're going to be talking about the trig identities today and using those trig identities. All right, the first thing I want to do is just kind of go through where these identities come from and label some different things to kind of help you out. So if this is our unit circle, we know that this has a length of 1 unit. We have talked about this being cosine, and just for our purposes, I'm going to quickly just write actually I'll write the whole thing. So if that's angle theta, this is from here to here, cosine theta, that x value. This y value is sine theta. So using just that triangle right there and knowing what you know about right triangles, we could write a Pythagorean identity using that. I want you to write what that identity is. Use the Pythagorean Theorem to write a statement using that triangle. On your own without talking. You get 30 seconds to do your best on it. Without talking. Huh? I want you to try it. It's Pythagorean Theorem. Apply it to a new setting. You can do it. Okay, time is up. This side squared plus that side squared equals that side squared. So we could write one of our identities as sine squared theta. And yes, we write it as sine squared theta, not sine theta squared, or theta squared. You're not squaring the theta amount, the angle amount. Okay. So sine squared theta plus cos squared theta is equal to 1 squared, which is 1. That is a Pythagorean identity. Yes? You could. Yeah. Okay. All right. We also know a couple things up here. We know that tangent is equal to sine theta over cos theta. That is tangent. We know cotangent is two things. It's 1 over tangent, which is also cosine theta over sine theta. Sorry, I can't make it any better. You can buy me a new camera. Okay. Best I can do. All right. Cosecant we know as 1 over sine theta. And we know secant as over cosine theta. Those are your reciprocal identities here. Okay. All right. To label where tangent is, now you're going to see this in many different ways depending upon how you, where you look and where you look online. I am going to, in this picture here, just so we have right triangles, notice all of these are right triangles. I am going to show you a length of tangent would be considered from here to here. Now, like I said, you're going to see that in many different ways and ratios set up. Tangent is just the ratio of sine to cosine. But giving you a picture form in this diagram, that would be a length of tangent. Whereas this point moves around, this length that's going from where that point intersects out to the x-axis is getting longer. Okay, that is your tangent. Okay, this length right here from there to there, which identity goes with cosine, or which function? Secant. That is secant. This length right here is cotangent. Okay, it goes from here to here. And this length right here is cosecant. Now, using those triangles, we can come up with a couple other identities. Using this triangle, write the identity, the Pythagorean identity you can get from this triangle right here.
What's this shape? That's like a pizza?
A sector, okay? Use the Pythagorean identity you can get from this triangle right here. Okay, anyone got it? Matt, what do you got?
Wait, no, not that. Secant squared theta. Secant squared theta.
Okay.
Equals 1 plus 1 squared is still 1 plus tan squared theta.
Good. 1 tan squared theta. So 1 plus tan squared theta equals secant squared theta. You have that right triangle right there. So once again, it's a Pythagorean identity because you're just using the Pythagorean theorem to find that. Yes?
So, instead of doing like the tan squared theta, could we do sine theta over sine theta all squared?
You could, except for now we're going to write it as tan squared theta, but that's what we're getting into in this lesson today. You're going to start moving things around based upon these different functions. Okay, so like for instance, Kendall said, could I just put this in for tangent? For now, I want you to write it like this. Okay. All right, the last one we're going to do is this one right here. Write that Pythagorean identity, please. For that other term. One plus
Cotangent squared theta.
equals. Good. All right. I can't remember what like a few years ago, some of my students came up with, sorry, there's the other identity. Some of my students came up with phrases here. Like, to remember this one, they said, I tan by the sea. Get it? I tan by the sea. I tan by the sea.
Oh.
Okay? I think this one was number one cousin. Okay? Hey, little phrases like, guys, seriously, I don't use them tons. I just remember them now, but I showed them in my class last year, and when both my kids got to pre-calculus this year and they started doing this, that's like the first thing they remember. So I can't remember. I'll look them up. I've got them written down somewhere. I just remember them. I use the picture, but it helps to have those little phrases sometimes. Okay? You could come up with other things here. Yeah. I'm going to stop right there. These are the Pythagorean identities that you will see. Okay, in fact, go ahead and look at your student journal, page 274. Page 274, you'll see those Pythagorean identities right there. Okay. All right. So, hey guys, here's what I need you to do. First, I need you to look at page 274 and not freak out. Okay? Because the reality is you know this one, you know that one, and you know that one. You know this one, and you know this one. You've been using those already. We discussed these. They shouldn't be terribly difficult. You will probably have to reference back, at least for these two. Okay, that's why I tried to give you like I tan by the sea. That may help you with that one. This one had something about like catching a cold or something. I can't remember, but I will look that one up. The ones that are a little more difficult, but we have talked about them, but the way they're written, the cofunction identities. This is just saying cosine theta is a shift of sine theta by 90 degrees. Right? If you take pi over 2, if theta is, for instance, if theta is 180 degrees, or actually let's go with 0 degrees. 90 minus 0. What is the sine of 90? Sine of 90 is 1, right? And, okay, the cosine of theta is 0. Okay? So, if I'm looking at this and I say, okay, well, if the sine of 90 is 1 and cosine of theta is 0 at that same spot, if I shift it 90 degrees, cosine is now 1 and sine is 0. Okay, all we're saying is that sine and cosine are 90 degree shifts of each other. It's a phase shift of 90 degrees. And that's what's being said here as well. Okay, tangent is a phase shift of cotangent. All right, we've seen that as we've graphed them. Okay, when you look at your graphs, you can kind of see that. So if you look back at your parent functions, those pages that we've done, you'll be able to see those. The other things that we've talked about, but we haven't actually put algebraic reference to, are these. Okay, so let's see if I've got a unit circle sitting here. Okay, so if we take a look at a unit circle, this says sine of negative theta is the same thing as negative sine theta. So sine of negative theta. So for instance, if I say the sine of negative 30, I'm going to just use degrees here. The sine of negative 30, they're saying, is the same thing as negative sine 30. Okay? So just let me explain it for a minute. Okay, sine of negative 30. So I start here and I drop down 30 degrees. The sine of that is negative 1/2. It's your y value. We good there? The sine of negative 30 is equal to negative sine of 30. So if I look at this and I go, well, the sine of 30, what's the sine of 30? Sine of 30 is 1/2. Okay, well, sine of negative 30 is negative 1/2. That's all that's saying. So what you're doing is you're really right here with your negative angle identities. They're talking about the quadrants you're in. So if you think about this, when I am starting right here at 30 degrees, okay, well, the sine of negative 30, that drops me down to this quadrant. So what was positive up here is now negative down here. So when I drop down a negative angle, I'm getting a negative output. So when I go down negative, I end up in a negative land for sine. Okay, when do I end up in a negative land for cosine? It's over here, right? So right here, this is saying if I drop down a negative angle for cosine, is it a negative value for cosine? So for instance, if I go cosine of negative 30, which one is cosine, x or y? It's x. Did this value change to negative? No, it's still positive, and that's what that's saying. Cosine of negative 30 is equal to the same thing as the cosine of 30. It's saying, look, if you go to negative 30, your cosine value, negative 30, your cosine value is the same thing as positive 30. That's all that's saying. That's what your negative angles are doing there. So rather than, you've done this, you just haven't put it in this format. Okay? So when I say the sine of a negative angle, well, when I drop from positive, when I start at standard position and I go downward, sine changes. So it changes its actual sign. It goes from a positive value to a negative value. Versus cosine doesn't change. All right, how many think you got what I'm saying there? Okay, that's what we're doing. That's all your negative angles are saying. Now notice tangent. Why does tangent actually change? Cosine doesn't. Sine does. Why does tangent? Yeah, because it's sine over cosine, right? It's tangent is sine over cosine. And if one of these change, if the tangent of negative, let's say 30 degrees, right? That would be the same as saying, rather than tangent negative 30, you could think, actually, let's just write it this way. You could think of that as the sine of negative 30 over the cosine of negative 30. Well, we know that cosine of negative is going to be the same as the positive. Cosine negative 30 is just cosine of 30. It's the same value. It doesn't change. However, sine does change. It becomes negative sine 30. It's the opposite of what sine 30 was. Therefore, we end up with a negative value here. U equal negative tan 30. That's what's happening there. Easy way to think about it, it's sine over cosine. This is negative, this is positive. Therefore, that has to be negative. Okay, so we went from picture form, where we've spent a lot of time now, to this is like way algebraic form. That is how we will finish the chapter. It'll be all straight algebra. Okay? All right. So, let's try some of these. Actually, any questions before we try some? Gonna be a hoot, man. I'm pumped. All right, 9.7, page 275. Walsh, pay attention. Just so you know, every time you do that, you pull people off task, and it makes it tough on a teacher that's trying to get through an extremely difficult lesson in a short amount of time and still have time to ask questions. All right. Not to mention, if you do that next year, a bunch of seniors in the class, you're going to annoy them really fast. Just saying. No, that won't happen. But you will get annoyed. Or they'll get annoyed. Okay, here we go. Find the values of other 5 trig functions of theta. All right. We're not going to do each of these right now. We're going to do number 1 and number 2 together. But the first thing we need to point out is they give you some crazy looking stuff here. First, they're saying sine theta equals 1/5, which may not seem all that like intimidating until they put this comma, pi over 2 less than theta less than pi. Okay, let's dissect what they mean here. This is giving you a it's giving you a quadrant to work in. Which quadrant are we in there? 1, 2, 3, 4. Remember, guys, the way we have named the quadrants, it starts at standard position. The first quadrant we go to, the second quadrant, the third. It's like rotating around, right? That's why they always go counterclockwise. So 1, 2, 3, or 4. Which one? It is in 2. We are over here. So what I do is I just put a dot over there to remind myself. I'm in that quadrant. What does that tell me? Well, it tells me sine is positive and cosine is negative. Key piece. Over here, we're in negative positive land. Okay? Kind of a crazy place to be. Negative positive land. Okay? We also know in order to find the other 5 trig functions, we better know all pieces of my reference of my triangle that I'm referencing here. Okay? So if I'm doing that, if I'm going to sketch this triangle out, tell your neighbor which sides you already know.
We already know the hypotenuse is 1, and then we know
Okay, time's up. What do we know? Oh, yeah, Jackson. Good. We know we know hypotenuse. That's the 5. And we know sine, or the opposite side, our y value. So this is 1, this is 5. What do we want to know? We want to find x, or cosine. Yes?
But it's not like word pair and the first number is x value.
It's still referencing a triangle, and you're still opposite over hypotenuse. So we're not dealing with a unit circle here, right? So we've got to break away from now just dealing in the unit circle world. Okay, we're now we now have a radius of 5. Okay, which means we have to find this length using the Pythagorean theorem. So our a squared, b squared, c squared. So 1 squared plus x squared plus or equals 5 squared. X squared is 24, and x is root 24, which is 2 root 6. Okay, so this is 2 root 6. How does that help? Well, you have all sides now. You now can list all of your other trig functions because cosine is adjacent over hypotenuse. So it's 2 root 6 over 5. If we know cosine, we can now also, well actually, we can just figure out tangent using this. It's opposite over adjacent, or 1 over 2 root 6, which rationalized is root 6 over 12. So we multiply by root 6 over root 6, so we get root 6 over 12. Sine, cosine, tangent. Let's go with, might as well do cotangent next. Okay, we just flip this one, so it's just 2 root 6. Cosecant is the reciprocal of sine, or 5. And secant, I'm going to have to move over here. Secant's the reciprocal of cosine, or 5 over 2 root 6, or 5 root 6 over 12. Yeah, it's pretty cool you know how to do this stuff. Some students could. What's cool is if you can do it and actually understand it. Because there will be a lot of students that will be able to follow along, like do the work, but they don't understand what they're doing. Okay? Don't just memorize. Understand what is actually happening. That's why we try to relate all this stuff back to a picture for you.
Next one.
Okay, questions on it? Do we have to make any of it negative? Oh yes, we messed up because we don't have any negatives. Which ones are negatives? Cosine is automatically negative because we're in negative world for cosine. So anything with a cosine in it, because one's positive and one's negative, when you do a ratio, a positive divided by a negative or negative divided by a positive, you're going to get a negative. So which other ones change? Tangent. So this needs to now be negative. Okay, cotangent is negative, and secant is negative. So the only ones that are positive are sine and cosecant. Very good job. Okay. Hey, I'm not going to work through all of number 3, but what I am going to tell you, a couple things. First, where are we at? Which quadrant? Yes, you're between 0 and pi over 2, which is 1. Okay? My triangle is right here. Based upon that and given cotangent, remember cotangent is what over what? So in turn, it's cosine over sine. Okay, and cosine is, good job, adjacent over opposite. How does that help? It means when I label my triangle and theta, notice I'm trying to get the same picture here. This is opposite. This is adjacent. That gets us started. That's how you start each of those. Okay. Now, hey, I'm not going to, we'll finish, you guys will finish those later. I want you to take a look at number 5. Number 5, simplify the expression. Negative tan over secant. This is where it gets a little more interesting. Okay? This is where you start using substitution. What is another name for tangent? Okay, let's write it in. I drop my theta when I'm doing this just because I put it back on at the end. That is just a habit I'm in. Don't forget it at the end. It's sine over cosine.
We're using like parts of like all of our math.
What is secant? 1 over cos. Now, I'm going to just put the negative on the outside here. It's going to follow along. Division like this is the same thing as multiplying by the reciprocal of that. What happens? It equals negative sign, don't forget theta. It's pretty neat.
That was surprisingly easy. That the last, like.
Okay, hey, let's turn the page. Actually, you know what? Let's try number 6 first. Number 6. Everyone figure out what another name for this is and what another name for this is. Take a look at your notes from page 274.
Wait, that means time.
All right, what's this become? That is sine theta. Anyone figure out what this is?
Sine squared theta?
That is sine squared theta. Now, hold on one second. For those that got the negative sign, remember this right here. That identity, if I subtract cos over, I'm left with sine squared theta equals 1 minus cos squared theta. Okay, so 1 minus cos squared theta is sine squared theta. Now, when I multiply these, what do I get?
Sine cubed theta?
Sine cubed theta. Yeah, I'm excited too. Okay?
Please tell me there's a lot of these.
Huh?
Please tell me there's a lot of these on our side.
There are some like that. Let's go on to number 7. Turn the page.
Some or a lot, because I like those. Those are fun.
You can do it. All right, number 7. Just for fun. All right. Hey, guys, some things to start looking at. When you see numbers in front, this means 2 times. You don't have to have 2 attached. You can think of it as 2 times secant squared x and 2 times tan squared x. That means, do you have another name for secant squared?
Yes, you do. It's 1 over cosine.
It is 1 plus what? Good. This is called 1 plus tan squared theta. Now, are we going to use that? Well, maybe. So, I'm going to write it there, and I'm not going to scribble this out so I can't read it. I just know that's another name. And right now, I can't simplify anything prior to changing it. Okay? Now, if I have 1 plus tan squared theta, and I have a tan squared theta here, I can do some simplifying up here in a minute. Okay, what is tan negative x? Look at your negative angles. That is negative tan x. What is cosine negative x? Cos x. Okay? Well, I can't put these together, but I can change tan x to, this was your question earlier, Kendall. Another way of saying tangent is sine x over cos x. Now, if I'm multiplying that by that, what happens there? Cosines cancel. My denominator becomes negative sine x. My numerator, I have 2 times all of that. Well, 2 times 1 is 2. 2 times tan squared x is 2 tan squared theta, minus 2 tan squared theta. What is 2 tan squared theta minus 2 tan squared theta? That's 0. So what am I left with on top? 2. Okay? Yep. Hey, how many are with me? One last step. Hey, yeah. Oh, yeah. You know what? I keep changing theta and x. If I do that, I'm actually doing it interchangeable. So those all those thetas are x's. Hey, last step here. This is 1 over that. This is the reciprocal. So this is 2 times, or negative 2 times, 1 over sine x. What is sine x? 1 over sine x, excuse me. Let's go secant.